Well, hello there, science fans. Have you ever looked up at our big, beautiful moon and wondered if it ever gets lonely? It turns out that Earth has more than one companion hanging around. Scientists have just confirmed some exciting news. Our planet has a new, temporary friend traveling with us through space. Say hello to 2025 PN7. This object is a small asteroid that has settled into an orbit very close to our own. It's not a true moon, but it will be our cosmic buddy for the next 50 to 60 years. It's like Earth has picked up a little travel partner for a long road trip around the sun. How cool is that? Now, before you rush outside to look for it, let's be clear. This new neighbor is very, very small. It's only about 50 to 60 feet across, which is roughly the size of a large truck or a small building. Because it's so tiny and faint, you won't be able to see it with your own eyes or even with a backyard telescope. It's a ghost in the night, silently following us. But just because we can't see it doesn't mean it isn't important. Its discovery gives us a fantastic opportunity to learn more about our solar system and the countless objects that zip around within it. This little rock is a big deal for science. You might be wondering if this new mini-moon will affect us here on Earth. Will it change the tides? Will it block out the stars? The answer is a definite no. 2025 PN7 is completely harmless. It is orbiting the Sun, not the Earth, and its path will keep it millions of miles away from us at all times. It is far too small and distant to have any gravitational pull on our planet. So, you can rest easy. Our daily lives will continue exactly as they have. But now we know we have a tiny, secret friend tagging along for the ride. It's a wonderful reminder of just how busy and dynamic our corner of space really is. This little asteroid is what scientists call a quasi-moon. It's a special term for an object that orbits the Sun but stays close to a planet for a long time. Think of it like two race cars on a circular track. Even if one car is in a slightly different lane, they can stay side by side for many laps if their speeds are almost perfectly matched. That's what 2025 PN7 is doing here. It's not attached to us, but it's keeping pace with us on our journey around the Sun. Over the next few decades, we will share a similar path, making this asteroid a fascinating object of study for astronomers everywhere. So, what exactly is a quasi-moon? And how is it different from our real moon? The answer lies in what each object is orbiting. Our big, beautiful moon is gravitationally locked to Earth. It circles our planet, held in place by Earth's gravity. It's a true, natural satellite. A quasi-moon, on the other hand, doesn't actually orbit Earth at all. Instead, both Earth and 2025 PN7 are orbiting the Sun. Their orbital paths are just so similar, and they are in such a special alignment that the asteroid is forced to stay nearby. It's a fascinating cosmic coincidence, a dance choreographed by the Sun's immense gravity. This special alignment is called a mean motion resonance. That sounds complicated, but the idea is simple. For every one trip 2025 PN7 makes around the Sun, Earth also makes exactly one trip. They are synchronized. Because of this timing, the asteroid is constantly playing a game of catch-up and fall behind with Earth. From our perspective, it looks like the asteroid is slowly looping around us in a strange corkscrew-like path. But in reality, it's just following its own orbit around the Sun. It's the gravitational tugs from Earth and other planets that keep this delicate dance going for so long. Unlike our permanent moon, this quasi-moon is only a temporary visitor. Its stable dance with Earth won't last forever. Over the next 50 or 60 years, tiny forces will start to push 2025 PN7 off its current path. One of these forces is called the Yarkovsky effect. This happens when the asteroid absorbs sunlight and then re-radiates that energy as heat. This tiny push of heat, happening over and over for decades, is enough to slowly alter its orbit. Eventually, these small nudges will break the special resonance, and our little companion will drift away from Earth, continuing its own lonely journey through the solar system. It's important to understand that 2025 PN7 is just one of several quasi-moons we know about. Earth has a few other small asteroid companions, like Kamoalewa, and 2023 FW13 that are in similar orbits. Each one teaches us something new. Some scientists even think that some of these objects could be ancient fragments blasted off our own moon by an impact long ago. By studying their composition, we can test these ideas. Each new discovery adds another piece to the puzzle of how our solar system formed and how materials move around in it. These tiny moons are like time capsules waiting to be opened. Discovering an object as small and faint as 2025 PN7 is like finding a single dark pebble on a vast black beach at midnight. It's incredibly difficult. This little asteroid was first spotted in August 2025 by a powerful survey telescope in Hawaii called PN7. This telescope's job is to scan the entire night sky over and over, looking for anything that moves or changes brightness. It takes pictures of the same patch of sky and then uses computers to compare the images. A tiny dot of light that has moved from one picture to the next could be a new asteroid or comet. That's exactly how 2025 PN7 revealed itself. Once the PN7 team flagged the moving object, other astronomers needed to confirm it was a real object and calculate its exact path. Scientists at the Minor Planet Center and NASA's Center for Near-Earth Object Studies took all the observations and crunched the numbers. They determined its size, brightness, and most importantly, its orbit. It was their calculations that confirmed 2025 PN7 was in a co-orbital state with Earth, officially making it our newest quasi-moon. So why did this little rock stay hidden for so long? The main reason is its size and darkness. With a diameter of only about 60 feet, it's one of the smallest quasi-moons ever found. An object this tiny doesn't reflect much sunlight, making it extremely faint. Astronomers measure this faintness using a scale called absolute magnitude, and 2025 PN7 has a magnitude of 26. For comparison, the faintest stars you can see with your naked eye are about magnitude 6. This asteroid is millions of times fainter than that. It only became detectable when its orbit brought it to a point where our most sensitive telescopes could just barely pick it out. The discovery of 2025 PN7 is a testament to how much our technology has improved. 20 years ago, we wouldn't have been able to find such a small, dim object. But with powerful survey telescopes and sophisticated computer analysis, we are now able to find these celestial ghosts. Each one we find helps us build a more complete map of our solar system neighborhood, revealing the hidden population of small objects that share our orbital space. You might think it's just a tiny, harmless rock. Why should we care? Well, in science, even the smallest things can teach us the biggest lessons. Studying 2025 PN7 is incredibly valuable for astronomers. Its stable, predictable orbit makes it a perfect, natural laboratory. Scientists can use it to test and refine their computer models of how objects move in a complex gravitational environment. By watching how this asteroid behaves over the next 50 years, they can check if their predictions match reality. This helps them get better at forecasting the paths of all asteroids, including those that might one day pose a risk to Earth. Furthermore, this little quasi-moon is an ideal target for future space missions. Because its orbit is so similar to Earth's, a spacecraft could travel to it using very little fuel. This makes it a cheap and accessible destination. A mission to 2025 PN7 could allow us to practice important skills for space exploration. We could test out new navigation software, practice delicate maneuvers around a small object, and even try out techniques for collecting samples. It's like a practice field for more ambitious missions to larger, more distant asteroids. This little rock could help us prepare for the next giant leap in space exploration. Studying these small companions also helps us understand the bigger picture of our solar system. Where did these objects come from? How do they move between planets? By analyzing the composition of quasi-moons, we can look for clues about their origins. As we've learned from the quasi-moon Kamo-Oalewa, some might be pieces of our own moon. Others might be fragments from the main asteroid belt, delivered to our neighborhood through a long series of gravitational nudges. Each one is a piece of a grand puzzle, telling us about the history and evolution of the inner solar system. Ultimately, every new discovery like 2025 PN7 changes our view of the cosmos. It reminds us that space isn't empty. It is a dynamic, busy place filled with countless objects, big and small, all following the elegant laws of physics. Understanding our cosmic neighborhood is not just for curiosity's sake. It's essential for our future. The more we learn about these small bodies, the better we can protect our planet and the safer we can make future space missions for astronauts. So let's give a warm, if distant, welcome to 2025 PN7. This tiny teacher has a lot to show us.